Okay, example 10. A woman with blood type O positive has a child with a man who is AB negative. Because we see the positive and the negative, that's letting us know that we're dealing with two different traits, the expression of the A and or B antigen or none, as well as the rhesus factor. So this is going to be a dihybrid cross. The first thing we need to do, as always, is set up our key. And I'm sorry, my handwriting's getting awful. Okay, so same thing we saw before. A, B, A, B, and O. And then I like to do, for blood typing, I do the RH factor separately. So RH or positive or RH negative. So we already discussed previously how we have two different genotypes, possibilities for blood type A. I'll try to write neater again. Same thing with B. And if we have blood type AB, that's codominance. Both are expressed. And O would be recessive. So for the RH factor, we just use the letter R to represent the rhesus factor. And again, positive is going to be dominant over negative. So we just need one dominant allele in order to be positive for the rhesus factor. And we would need two recessive alleles in order to be negative for the rhesus factor. So woman blood type O positive. So she has to have two recessive alleles and at least one dominant allele, has a child with a man who is AB negative. Okay, clearly I didn't provide enough information on this one. So let's assume that she was a heterozygote for the rhesus factor, which would indicate that her second allele would be a recessive allele. All right, so set it up just like your standard dihybrid cross. Okay, you can go ahead and determine all the potential genotypes set up this way, or you could do the shorthand method. Like I said, if you reduce down the numbers that you get for your phenotypes, you end up with the same result. Because this column is the same as this column, I can cross this column out. And because this column is the same as this column, I'm going to go ahead and cross this. What happened to my... Okay, I'm just going to redo it. Same thing when we look at parent 2, the top two columns are the same, so I can cross one of them out, and I can cross out the bottom column because those two are the same as well. So we really only have to solve for four of our offspring's genotypes. Okay, so let's see what we have. We have A positive here. Let me go ahead and write this down. And we have A negative here. And then we have B positive here. And we have B negative here. So these are all in a 1 to 1 to 1 to 1 ratio. Again, if you had filled out all 16 of these squares, you would have found that these 4 phenotypes from these offspring were in a 4 to 4 to 4 to 4 ratio, which would reduce down to 1 to 1 to 1 to 1. So you can eliminate things that are the same and leave only solving for those that are different, or you can solve them all out. It's totally up to you. Either is acceptable.